Thank you all for coming out today. The first speaker we got for track one is Joe Woods. He's VP of Engineering with Mobius. He's also created rvatechcalendar.com, a calendar of free tech events, and he's a VCU grad. So without further ado, all on you, Joe.
Thanks so much. All right. Thanks for coming out, everybody. I appreciate it. Thanks for taking a chance on a really weird talk title. The short version of this talk is that this is kind of like an idea for an article I had in my head for a long time, and I kept trying to write it, and it never worked. And then Galen was like, "Hey, you're giving a talk, right?" And I was like, maybe. And he was like, "You're giving a talk, right?" And I was like, "Sure." And this idea came to mind, and I was like, "Yeah, this would be a great talk." And then I started writing the talk, and I was like, "Oh gosh, now I have to talk about Wikipedia." So here we are. Hi, I'm Joe. I'm actually a VCU grad. It's great to be back at VCU. I'm the VP of Engineering at Mobius Materials. I think like half of our company is in this room right now, which is really great. If you're interested in hearing more about Mobius Materials, we're keeping heavy metals out of landfills. I'm like very, very proud of what I do. And so if you're interested in hearing more about that, come talk to me. I also run this website called RVA Tech Calendar, which is a calendar of free tech events happening in Richmond. You should check it out and subscribe. And I do a bunch of other stuff. Yeah. So yeah, like I said, this is a photo I took of the library on my last day of working at VCU. I have 2 degrees from VCU. I got my master's here while working at VCU libraries. And so I haven't been in a VCU building in like 6 years. So it is really interesting to be back. And it's also bold of Galen to schedule a conference at VCU on the same day that VCU's in the A10 tournament. So go Rams. So I said I have a master's from VCU. I actually have a master's in English, but I'm an engineering leader. And you might ask, "Hey, that's weird." And I'll say, "Yeah, you're right. That's not really a question, though." I think part of the reason why I'm so kind of attached to code is that it's just applied problem solving. I think really, as you learn how to become an engineer, you have to think about the way to describe problems in a way that the computer can understand, right? And so for me, at VCU, I learned that history is important. This is a picture I took when I was working at this artisanal letterpress shop. Like I set most of this type, I had help with this one, but I set most of this type by hand. This is actual lead type. And like during that process, I learned what an M was, right? Like a literal lead M goes into type, right? It's like this little gap that you put between words to space them out, right? And so the CSS unit, M, comes from this like 1,000-year-old technology. And I think that's super cool. And I'm never going to forget that. And I also know the weirdness about how M's work comes from the weirdness of how people have to use their hands to put lead type into frames. And so when I think about problems, I like to understand kind of the history of how we got here, right? Like, why is this the way it is? Because who here has heard the parable of Chesterton's fence? Chesterton's fence? Yeah, one. Okay, so I talk about this a lot. Chesterton's fence is basically like, I'm going to totally butcher this, but like someone goes to General Chesterton or whatever and it's like, "Hey, there's this fence in the road and it's preventing our army from advancing or whatever. Like we should tear it down." And Chesterton's like, "If you can tell me why that fence is there, you can tear it down." And that's super important when we think about code, right? Like if you go in and you just like blow up a module or whatever and you're like, "Oh, we don't need this." And then 1 year from now you realize, "Oh no, my company's on fire." You probably should have heeded the parable of Chesterton's fence. So history is important. It's not just important because it's interesting and fun and exciting. It's also interesting because it means that you can prevent making mistakes in the future. Few disclaimers really quick. I know this talk is being recorded, so if you're 5 years from now and you're like, "Oh, he said 2009 when he really meant to say 2010, don't at me, please. I'm just going to sum this up as quick as I can. I'm doing most of this from memory, and so I'm going to get details wrong. Do your own research, please. Don't take anything I say here as gospel." And yeah, it's like a really quick talk, so it's just gonna be wrong sometimes. Also, really quick disclaimer: if you're photosensitive, this is dark mode, right? There are a few slides that are in like light mode, so just warning about that. Speaking of slides that are in dark mode, here's a hot take I have: JavaScript's weird. I think like most people will probably agree with this, but I think there's 1 or 2 people that are like, "Oh, it's not that bad, right?" No, it is. and it's not bad, but it is weird. And I will definitely die on this hill. Like, this is an opinion I hold really strongly. Here's a really golden example of that. Any expression in JavaScript is throwable. So if you want to say like, I want to raise this exception, what's the exception? It's 1. You can do that. You shouldn't, but you can. And that's really weird, right? There are other languages that let you do this, like Ruby, for example. And there are other good languages that let you do this, like Erlang. But the thing is, there are other languages that did let you do this, and they got to change it. So Python, you used to be able to throw anything. And in 2005, they're like, you know what? That's bananas. We shouldn't let that happen. And so they just decided to not let that happen anymore. And now everything that you raise in Python has to be a subclass of the exception class. But if JavaScript was just like, oh, and by the way, you can only raise an error that's an error, right? Not just one. If any website relied on that behavior, that website would break. And JavaScript is one of those languages that's backwards compatible, which means we don't do that, right? Any code that's shipped to the web now, there's basically a guarantee that's always going to work if your web browser is pointing at it in the future. And if you think about it, that's like a really heavy choice to make, right? A lot of the features of our language are baked in from these decisions we made a long time ago, and they're very, very hard to shift. One example of this is the use strict directive, right? Directives, this is just like a thing that can exist in computer programs. But if you think about use strict, like this is a string literal, right? That you're just like sticking at the top of a file. And so if you're like in an ES3 execution environment or whatever, it's like, okay, cool, it's a string and it moves on, right? But we decided, hey, the way to fix some weird stuff about JavaScript is just have a string there. This gets you into strict mode. I actually learned while looking into stuff for the talk that the opposite of strict mode is lovingly referred to as sloppy mode. And I love that. That's a great name for it. So strict mode is great because it fixes a lot of weird stuff about the language. And it also means that we can say, okay, well, when we get new stuff, right, like ECMAScript modules, for example, every module is always already in strict mode. Also classes, I don't know if you knew this, but you can have the boundary for strict mode be at the function level as opposed to at the file level. So every class, every method within a class is also always in strict mode. You never have to worry about this, like your transpiler just does it for you. So you probably shouldn't worry about it. But there's a lot of cool stuff that strict mode gave us, right? I don't know if you were there when you were writing code in like 1999 or whatever, but your JavaScript used to be able to do this. You could say undefined is 5. And the like Netscape Navigator interpreter would be like, "Yep, gotcha, boss," and just like move on. That's weird. You shouldn't do that. And so when you're in strict mode, this is a type error. And that's way better. Like you want that to be an error. You don't want to be silently ignored. Strict mode does a lot of really cool things in that it's cool that we don't let it happen anymore. And the decisions that went into the things that strict mode prevents are like totally wild. Like the way that variables used to work is wild. You should look into it, but I'm not going to get into it too much. Yeah. Here's another weird thing about JavaScript. Everything's an object, except for the stuff that's not an object, right? This is kind of the classic example of stuff that gets combined in JavaScript in weird ways. Here's a quote from JavaScript's Wikipedia article in 2004. By defining a constructor function, it is possible to define objects. JavaScript is a prototype-based, object-oriented language. That means that inheritance is between objects, not between classes. JavaScript has no classes. Well, great, we fixed that, right? We've got classes now. It's awesome. But when ES5 came around, you could do prototype inheritance, right? It's just, it kind of was not fun. It was a bad developer situation. You didn't have good developer ergonomics. So this is the way you used to have to deal with inheritance. You had objects, you could create just a normal object, and then you could extend it, and then you could give it a property, and great. Like you basically reinvented your class. And through here, you could set the prototype of any other class that you construct, and that gives you a prototype chain, right? And it kind of feels like prototypal inheritance, and that works, but it's not a good kind of like UI, a good interface for actually writing that code. And then so ES6 comes along and it's like, hey, we've got classes. And this is clearly so much better, right? This is what like a computer programmer is expecting to write. And from here, it's obvious, okay, what do you do with this class? You can extend it. You can do cool stuff. When this first came about, classes were just like spicy objects. If you go look into classes, a lot of articles will say, this is really just syntactic sugar for the other way. I'm here to tell you that that's not true. Like in 2025, you'll read a lot of articles that are like, hey, this is just a fancy object, like it's really just syntactic sugar. That's definitely not true anymore at all. So those articles are liars because they happen to live in the past. Now, classes do a lot of really cool stuff, right? It took a while, but we set up the infrastructure to be able to do like real programming things, like have private class properties, which are super useful, getters and setters, and more things that I don't remember off the top of my head. But at the end of the day, they still belong to this object prototype chain, right? So here's the last sentence from the first revision of the JavaScript Wikipedia article from 2001. The primary data structure in JavaScript is an associative array similar to hashes in the Perl programming language. Strings are objects. To do, more information on the language. Is anyone here familiar with Perl? Okay, a few people. Yeah, I mean, I think it says a lot about like the environment that JavaScript was coming up in, right? At this time in 2001, ES3 was still relatively new. JavaScript was kind of a toy. It was missing a lot of features that you would expect from a programming language. It was designed to be this thing that kind of like moved text around the screen when the typical HTML and CSS that you had weren't good enough. And so if you interacted with JavaScript back then, you knew it wasn't a real programming language because it was really, really slow and it was really, really buggy. So if you wanted to make an actual application for the web, you just kind of couldn't. You would write your code and be like, wow, this is horrible user experience. This code that I expect to be moving stuff around, like just it's taking seconds when it should take milliseconds. And like most of that was just because you were living in the past, right? I think some of us forget that this is what 2001 looked like. This is what a phone looked like in 2001, right? Sometimes I have conversations with people and they're like, oh yeah, the rate of human progress isn't really accelerating that much. And I'm like, but this was a phone. I was there. 3G was like just starting to be rolled out. Like the iPhone wouldn't come around for another, I want to say 6 years. So like, imagine trying to think about like JavaScript for the web on phones when this is what phones look like. And so this leads me to another hot take. Anyone who tries to tell you that they know what programming is going to look like in 20 years is trying to sell you something. Listen, I absolutely do not want to talk about AI as part of this talk, but I do think software engineering is going to be around in 20 years. It's just we have no idea what it's going to end up looking like, and I don't think that's AI's fault. I do know, however, that 20 years ago, everyone was still training themselves to be able to hit a moving target, right? As we've thought about going into software engineering, as we've thought about building stuff, right? You can kind of have a vague idea of the area you're going into 1, 5, 20 years from now, but the second that you turn those into concrete expectations, like you have to make sure you have some leeway in there, right? So as you think about, okay, well, how do I be prepared for the future? If I'm a new grad, how do I get a job? Just realize the environment you're entering into today looks kind of not a lot like the environment you're going to be in 5 years ago, and definitely nothing like the environment you're going to be in 20 years from now, because that's what phones looked like 20 years ago. Okay, so how did JavaScript go from being this kind of like toy that wasn't very good or fast to being this like fully featured language with actually like interesting features, interesting things you can do with it in 2025? And the reality is, like every good process, it wasn't just like dumped onto a community, it was evolved over time. So this is a screenshot from, I want to say this is like the ECMAScript version history Wikipedia article today. And if you look really closely, you'll see that we have ES3 that we just talked about from 1999, and ES5 in December 2009, a 5-year gap, and this thing called ES4. And you might be wondering, what? That's weird, right? We skipped one. What happened there? And also, you'll see 4th edition was abandoned due to political differences concerning language complexity. That's really concerning. Like, if you're just starting to get into JavaScript and you're like, wait a second, there were political differences in this thing that's paying my bills, you're probably right to be a little bit concerned. Let me explain. So the ECMAScript article from 2004, okay, actually, let me take a step back. I realized I totally skipped something earlier. If you're not familiar, JavaScript is like the concrete instantiation of this thing called ECMAScript, right? The ECMA International, like it's ECMA 262. This is just the standard way to think about what JavaScript actually is for the most part. And so when people say ECMAScript, they really mean like the JavaScript standard. You can kind of use these things like in the same sentence and they kind of mean the same thing. Don't really worry about it. But that's what I'm talking about when I say ECMAScript. It's like the actual standard itself. And so the ECMAScript article from 2004 mentions the unfinished ECMAScript 4 recommendation. And it says, oh, here's all these things that are based off this unfinished recommendation. And it's talking about the things that you probably like don't recognize. Like Netscape Navigator, it uses JavaScript. That's cool. IE, Internet Explorer, uses this thing called JScript. And then Opera, it kind of does both, right? So here's a lot of sentences that like, or a lot of words that don't really exist anymore, which is very interesting, but they were the environment that people were in. So yeah, what are these things? What are JavaScript, JScript.net, ActionScript 2? So different environments in the world in like the late 2000s needed to be able to accomplish different things. And so it was just that the development of JavaScript wasn't meeting those demands. It wasn't moving fast enough to be able to accommodate these companies that wanted to be like, hey, let's like actually move stuff around on people's screens. Let's actually create like interactive UIs in web browsers. Here's a quote from 2004. The programming language used in Macromedia Flash, called ActionScript, bears a strong resemblance to JavaScript due to their shared relationship with ECMAScript. ActionScript has nearly the same syntax as JavaScript, but the object model is dramatically different. You have this company, Macromedia, they had this thing called Shockwave, and they had Flash, and they were like going into people's browsers, and these artists were like, hey, I can make like actual art in people's browsers. Like, you have these really cool things like homestarrunner.net, it's .com. I still reference HomestarRunner all the time. Flash was cool. And actually, this is another hot take. Like, the world is worse off without Flash. I don't know if you remember this time. Flash, like, it was bad, right? And I'm not gonna like pull any punches on that. It was not accessible when you think of like people that don't, like people that are low vision, you could not use Flash. It was also controlled by one single corporation and a bunch of security issues. And it was also kind of slow. Like it wasn't the future that we wanted. And so Flash kind of started to go away when Apple was like, we're not putting this security hole laden thing that's controlled by another organization on our iPhones. And I think they were right to make that decision. But we still don't have this kind of like cultural moment anymore, right? Like people aren't making stuff like Homestar Runner anymore for the open web. They are kind of making stuff like Homestar Runner, but it's like stuff that's going on like, there is a Homestar Runner. It's on TikTok and it's called Skibbity Toilet, right? And it's not the same. I miss this a lot. So, okay, what happened to ES4? This used to be a bunch of slides and I was like, you know what, that's not gonna be very fun. I'm not gonna just sit here and read. So I'm just gonna sum up my understanding of what happened in this period of time. So, like I said, JavaScript's mostly a toy, and also TC39, the group that's like developing the JavaScript standard, they're mostly doing nothing. It's like not an active working group whatsoever. But you did have companies that were making web browsers that wanted to be doing more, right? Microsoft is fresh off of putting Internet Explorer on basically everybody's computer, which more or less killed Netscape Navigator. Netscape was like the primary web browser that everyone used. And then Microsoft was able to corner that market. They're like, great, this is awesome. Let's keep this momentum going. They were developing this .NET platform, right? People are familiar with .NET, and they wanted to provide a kind of scripting-like execution environment that would compile to .NET. So they're working on this thing called JScript.NET that looked a lot like JavaScript, but was a compilable language, and it had like really cool language features like we would expect, like classes, yay. Meanwhile, Macromedia is like, hey, this internet thing's really cool. People are doing this cool art stuff, like homestarrunner.com. We should do more of that. And so they kind of start talking about, with this company that's kind of rising from the ashes of the now murdered Netscape Navigator. You might be familiar with them. They're called Mozilla. And they're just talking, right? Like, hey, what does a fully featured open language kind of look like? And they start working on this kind of JavaScript 2 concept. What is an actual programming language for the web? What does that end up really looking like? And so Microsoft, they're like, hey, it kind of sounds like you're having this conversation about this really complicated language that's going to take some time to develop. And it's not this thing we're developing. So we're off on this complicated direction, and you're having these secret meetings without us in this complicated direction. And some developers at Microsoft are like, it's going to be a lot of work. It's going to be really annoying. It's a different kind of complicated. And then some lawyers at Microsoft are like, this is going to be really annoying. You're cutting us out of this process that's supposed to be an open process. And so there was a lot of drama and a lot of emails. And then Brendan Knight came back in and he's like, okay, we should take a step back. Y'all can keep working on ES4, but let's talk about a smaller, more iterative change, right? Let's call it ES 3.1. And let's actually develop, okay, well, what do we need to do to make the current state of JavaScript something that people can actually use? That's not slow, something that people can really use to start building applications for the web. So they went off and they worked on it, and they came up with what basically now became ES5. And in the process, they're like, what do we do to make sure this never happens again? And so they set up a process by which you can iterate on this language, develop it, and bring new features to it over time. And so they do that, and they're like, hey, this ES4 thing has got a lot of baggage with it. It's bringing up some bad feelings, so they're just going to skip it. Went to ES5 correctly. Which is great. Now we have this fully featured language. It's awesome. So here's a quote from the 2009 Wikipedia article for JavaScript. JavaScript has become one of the most popular programming languages on the web. Initially, however, many professional programmers denigrated the language because its target audience was web authors and other such amateurs, among other reasons. The advent of Ajax, which is like the precursor to the Fetch API. Don't worry about it. Also, ES3 used to not be able to transact with other stuff. It used to be really complicated. You couldn't really make web requests without doing some complicated stuff, and that was another reason why you couldn't really use it as a programming language. And that fixed it, and people were like, yes, this is a real programming language now. So that also returned JavaScript to the spotlight and brought more professional programming attention. The result was a proliferation of comprehensive frameworks and libraries, improved JavaScript programming practices, and increased usage of JavaScript outside the browser, as seen by the proliferation of server-side JavaScript platforms like Node. And yeah, great, we did it, we won. JavaScript isn't a joke anymore, right? And I think sometimes you still get a little bit of that, maybe not so much in 2025, but there is still kind of a vibe where it's oh, you're a front-end developer, you're not a real developer. And I think some of that, I'm trying to be generous and say that a lot of that's coming from this. The reality is JavaScript is this fully featured programming language, right? even if people are interacting with the design elements of HTML and CSS as the interface with the JavaScript, there's people who are real programmers, and anyone who has that take, I totally disagree with people that believe those people aren't real programmers. But I think there is kind of the inverse of that, which is a hot take, which is, well, if someone's trying to say, oh, well, you just write JavaScript, the easiest argument against that is no, I write all the other languages too. I just like this one the most because it's the most useful. There's this concept of T-shaped people, right? When you think about expertise, you have this narrow band, which is hey, I have my PhD in this specific field of math, right? And that is definitely a valid course of someone's life to go on, right? And there's another valid course in their life, which is this horizontal band, which is jack of all trades, master of none, but better than a master of one. If you combine those two, and it's hey, I've got a rough idea about how all these other things work. And I know enough to be dangerous, but also I have really specific expertise in this really narrow field. I think that's the easiest way to get hired, where it's hey, I'm really good at this one thing, and also if you need someone to wear this other hat, I can do it. But just keep in mind I'm the expert at this other thing too. So yeah, I think everyone should go and aspire to be T-shaped at least. So yeah, ever since then, JavaScript has been continuously evolving. If you don't know, ECMAScript publishes this yearly standard, but the reality is that the yearly standard is just kind of what is JavaScript already, because web browsers are being part of this process, and they're saying, okay, here's an idea for a feature. We know it's at stage 3 in the process. We implement it, we ship it. It's JavaScript now, and then ECMAScript comes back and they say, hey, great, it's JavaScript now. There's a team of people, TC39. Everything that wants to become JavaScript goes through this process. What does that process look like? this is what that process looks like. So someone comes with an idea, and it becomes a stage 0 proposal. Anybody in the world can make a stage 0 proposal for TC39 at ECMA International. So if you're like, I think that JavaScript should have channels, like just do it. You can like submit a proposal to TC39, and you actually should, because it'll be fun. In order to go to stage 1, it has to have a champion on TC39 that's going to help evolve the proposal and push it forward. And they take it to TC39, they talk about it, and then they turn into a stage 2 proposal, which says this is how it's going to work. Once they get there, they evolve it. They say, well, okay, when we go to implement this, like, what does it really concretely look like? Once they figure that out, it goes to stage 3. And actually, this slide is from, I just copied it from a talk I gave like 18 months ago. And at that talk, there was like a literal human child. He was very, very smart, but he was also a child. So he was like, hey, who's the enemy? And I had to have this like, kind of like, derail. Okay, so there's this joke where it's like, yeah, like my application is derived contact with the enemy and the user is the enemy. And we're not trying to be mean, but it really is like you have these plans and then you put them in front of the user and they do stuff that you're not expecting. So like, don't worry about it and like keep that youthful positivity. What I'm trying to say is I probably could learn a lot from that child and I don't know if I did. And then you get to stage 4 and it's JavaScript. Yay! So what does it mean? Just to reiterate, each of these stages is a signal. Right? Like stage 0, someone said, I think this should be JavaScript. And then when it gets to stage 1, it's really like there's a human being that's like, has, you know, agency in this environment that says we expect this to become JavaScript. Stage 2, it's like, okay, yeah, like we basically think we're done touching it. Stage 3 is it's kind of in the browsers already. And then stage 4, it's like, hey, everybody, like this is JavaScript. If you write something that doesn't have this in it, it's not JavaScript. And actually recently, at like the end of 2003, they realized that stage 3 was kind of doing too much, and they realized it should be 2 different stages. In stage 2.7, I have no idea why they picked 2.7, by the way. They're like, let's actually make the testing integration environment first, and then go on to stage 3. Okay, and also I should do a really quick mention. I was kind of lying to you a little bit. Not all of JavaScript is ECMAScript. There's this thing called the W3C that was founded by Tim Berners-Lee, the guy that invented the internet. And they also do like standards for the web. And so if you think about crypto, like the web cryptography API, that's in every browser, but it's not part of ECMAScript. You just have to kind of know, and it's here. And the standard lives on a different website, but it's there. So the W3C, they do other stuff too, but like most of the JavaScript stuff, they try to funnel it into ECMAScript. And like I said, you can totally participate in this process. If you want to be on TC39, your organization just kind of joins ECMA International, and that's it. And I'm kind of glossing over an important detail, which is like, this is really expensive. So what I mean to say is, if your organization has like $80,000 just kind of like lying around, then you can participate in TC39. But you can still hang out. I have commits in the proposals for decorators and shadow realms because I read the proposals and I was an English major and I was like, let me help out here. Let me help clarify this or fix some broken code examples or something. Like you should just go do that so you can give talks and brag that you have commits in the decorators proposal. Yeah, and speaking of decorators, this means that JavaScript is getting some features I'm legitimately excited about. It means that you can talk about programming like at this deep theoretical level with this language that was once kind of a toy. In 2005, the JavaScript Wikipedia article had to kind of go into depth about like, hey, if you want to do some cool stuff like traits, for example, you can. It natively supports that, we promise, but like in reality, like it's kind of verbose, right? You're not gonna have a fun time trying to implement that. But like, whoops, where did I go? This is in a lot of browsers now. These are 2 decorators in this code example. And so if you're not familiar with the decorator, this is something like you use in Python all the time because you just say like at something, and that's a method that gets past the context. Like this is a class that will get passed in and will return the wrapped class that comes back as a result from that method. And so that was a really bad explanation to just say like, it decorates the thing, right? It takes it and you can like hang stuff off of it or change its internal like scope or stuff like that, like basically anything you want. It's way more complicated than I'm making out to be. And also it introduces this kind of like complicated accessor thing that I don't want to get to. That's like a proxy for getters and setters so that you can also decorate specific properties within classes. It's super cool. You should check it out. Another really exciting thing that's coming to JavaScript is this thing called temporal. And so immediately after this, you should go to track 2 because Gareth is going to be talking about temporal. Here's a hot take everyone already agrees with. The date built-in is really bad. And so Gareth's going to tell you about why we're fixing that as like a JavaScript community. So yeah. Also, another thing about JavaScript that's now in every browser, like I think it just was in ES 2024, is new methods on the set global, right? And so ES6 got sets, and they were just like, it's an array where every value has to be unique, and that was kind of it. And if you know anything about math, you're like, but that's not what sets are, right? I want to do math here. I want to know what the union of these sets are. I want to know what the symmetric difference of these sets are. And you can do that now. That's really exciting. If you're like me and you really like advent of code, it's like, wow, I get to write way less code so I can solve problems for Santa. So yeah, set methods. They're really cool. Check it out. Another thing that's, I want to say exciting, but also like generating some interesting conversations is that there's a stage 1 proposal right now to bring type annotations to JavaScript. So that thing about TypeScript that lets you do static analysis, like, hey, this function expects this parameter to be a string, but you're trying to use that as a number here, that's going to be an error in production. Like the value proposition of TypeScript, you're trying to add that to JavaScript so that the browser or your execution environment just kind of ignores it, but your IDE, your development environment can help you out. And this is like generating some really, really interesting conversations. Like, hey, TypeScript in the beginning used to have a lot of these language features baked into TypeScript that got transpiled to JavaScript. For example, decorators, right? TypeScript had a lot of early adoption because it brought stuff that you actually needed to write good code, like decorators. Slowly, those are being added to JavaScript. It also means a lot of people like enums or enums in TypeScript. It's just a way of having like an object with like static fields where it's like, here are the options for some choices for a thing, and you can throw that around in your code. If type annotations are added to JavaScript so that people are like, oh, okay, I can just like replace, I can copy, grab all my TS files and replace them with JS, and you're still using that feature, you're gonna have a problem. And so this is becoming an interesting conversation as well. But another interesting conversation that comes out of that is that like, okay, well, if we fix all that, do we really need TypeScript anymore? So here's a really hot take that I hope is right. I think JavaScript's just gonna eat TypeScript. Like just in the same way that JavaScript ate jQuery. Like it used to be that in order to write good JavaScript code, you basically had to use jQuery. Like it became super popular because it was the best choice. Right now, TypeScript is really popular because it really is the best choice. What's going to happen when it's no longer the best choice? And so, yeah, hopefully 5 years from now, I can be like, got him. JavaScript has gotten so good that it's become the default, and it just keeps getting bigger. People are putting JavaScript on like microcontrollers, and I think that's kind of absurd. Here's a Wikipedia article from 2015. JavaScript is considered an assembly language of the web, a compiled target of source-to-source compilers for making client-side web applications using other programming languages, supported by all the major browsers without plugins. If you think about that, that's a huge promise. You're saying, hey, this is the platform of the web. If you think about like write once, run anywhere, like the Java slogan, JavaScript's like actually doing that, actually fulfilling that promise because everybody's just got a web browser. I think that's awesome. And I think it's awesome that people are also saying, well, okay, well, how do we take that same conceit, everyone knows JavaScript, and put it places it absolutely does not belong? I have this thing called a flipper zero. I don't know if you're familiar with it. It's like this Tamagotchi that allows you to like inspect radio waves going on around you. Like, hey, I toggled that Tesla's charge port. Haha. They're a lot of fun. You can write JavaScript for that. Like it's a strict subset of JavaScript, MJS. But like the Flipper Zero is running this STM32. It has like 1 megabyte of flash memory. That's why are you trying to put JavaScript on that? Like write a different language. But I mean, I say that. I also think there are like very, very few reasons why I wouldn't choose JavaScript for a new project in 2025. And I think that's saying a lot. Like embedded hardware, yeah, I would probably like pick Rust or whatever. But other than that, JavaScript kind of does everything. And that's super cool, especially compared to 20 years ago. And that's only going to keep picking up steam as the web ecosystem continues to evolve. You all have probably heard of WebAssembly. If you're not super familiar with WebAssembly, you can just think of it as a compiler target. Like if you have compiled code, instead of targeting like one specific platform like ARM, you target WebAssembly, like this thing that is executed by WebAssembly environments, browsers, but also like Dino. And so in June 2025, 2 years before its first release and 4 years before it became a W3C recommendation, people were super excited about it. They're like, hey, all the 4 major web browsers, including Internet Explorer, they've really come together to work on this, like, this framework, this thing that everyone's going to be using. To the point where one of the co-founders of Docker in 2019 said if WASM, WebAssembly, and WASI, the WebAssembly System Interface, existed in 2008, we wouldn't have needed to create Docker. Like, that is mind-blowing to me. And he said that's how important it is. WebAssembly on the server is the future of computing. And so, okay, I'm not done a ton of time, so I'm going to rip through this really quick. Why is WebAssembly exciting? WebAssembly can run instantly. It streams like just like a video, right? So you have WebAssembly, you start downloading it, and you can immediately start executing it. That means that theoretically, if you have like a serverless thing, right? You have a function that needs to run every time someone hits an API endpoint. The startup time, like the cold start time, could theoretically like approach 0, right? You don't have to wait for a computer to boot up. You don't have to wait for an operating system. It just starts going, and that's super cool. It's sandboxed in the same way that Docker is sandboxed. You give it like these boundaries, this is the stuff it has access to, and that provides security out of the box by like the principle of least access. But if you need to give it access, there's this really cool environment called the WebAssembly System Interface. So you can say, hey, I need a defined way for this thing to get access to a clock. And it just gets access to your system's clock. Obviously, you're not really going to get that in web browsers in 2025, but if you're running on a server, that's super important. And this is also just like where a lot of the cool folks are hanging out. Like if you want to talk to people that get really excited about code, like get really into WebAssembly. Because of these things called like WIT worlds, which recently changed names, where it's like, this is the way that we define the standard interface for defining standard interfaces. So if you want to say like, if you want something to look like this type of computer, you define a world so other people can then export to that world and like write modules for that. It's like a shared module system for this low level compile time target, which is super cool. There are like entire languages springing up that target WebAssembly as a compiler target. Check out Grain, really nice folks. They get to do like cool math stuff with programming languages and target the web, which I think is awesome. And like for all those reasons combined, I think that's why WebAssembly is going to be this like future thing. Like right now, yeah, there's a lot of cool stuff happening with WebAssembly, like Figma, for example. Why is it so fast? Well, it's really just targeting WebAssembly under the hood, right? That is super, super cool. And that's only going to expand as time goes on. But one thing to note is Solomon said this in 2019. That was 6 years ago, which is like a mortal age in JavaScript land, you know? Like, I'm surprised we're not talking about this more, I guess is what I'm trying to say. And so kind of by means of wrapping up, I hope that even if you're like a distinguished staff engineer or you have tenure or whatever, you don't think that you're done. You know, there's still cool stuff happening that you need to stay on top of, and you should be excited to learn more about. Actually, you know, I don't think this should be a hot take. I think you should just stay curious. It's really easy to become a defeatist and be like, oh, AI is going to take my job or whatever. But that's only part of the reason why the target is moving. The deeper the understanding you have of the environment you're working in, be it JavaScript or Python or operations or medicine, the further you're going to be able to take these ideas, the more interesting conversations you're going to be able to have, and the harder problems you're going to be able to solve. The deeper you understand something, the easier it is going to be for you to take it apart and put it back together. And that's my hot take. Thanks so much. All right, we've got like 5 minutes. Does anybody have any questions? With the caveat that I probably won't have an answer. Yeah.
You, first of all, I'm just going to preface this by saying I'm a total novice. But anyway, you talked about the ECMAScript approval process where you go through the phases. And there's a phase where, like, in essence, some browsers are already doing it.
Yeah,
Like, how does that actually work?
yeah, that's a great question. Like, what are the like physical logistics behind that? Or
Well, I'm just thinking like, why, you're producing a web page or whatever, right? And you've got script that only some browsers can use,
Yeah.
or like, why go there?
So a lot of the reason why these things are added to the language is because people are really excited to use them. And so in some cases, people will be even, let me take a step back. So for each of these features, one of the things they work on is a way to transpile that to code that older browsers can run. So decorators, for example, you can write the code you want to write in your environment, and then until it's in every single browser, the thing that your compiler, your transpiler is actually generating doesn't actually use that feature. Until enough time has gone on and the thing underneath the hood that is like doing that translation says, okay, like you've reached the threshold you've defined in your code or create React app has defined for you. And then that says it's time to switch over. And so even if you have like 70% surface area covered by Chrome, and actually Chrome is probably more like 90, sometimes your environment still won't transpile it over. And that's kind of how it works, just transpilation, that ecosystem.
Thank you.
But yeah, it is kind of weird that some browsers have this fun, exciting thing. And there's this cool thing happening called Interop, where every year Safari, Firefox, and Chrome come together and they're like, these are the ways that we aren't really meeting the promise. Like these are the kind of weird things that aren't quite right about our environments. And they write a bunch of tests, and it's kind of like not really a competition, but it really is a competition where they're like, how do we get as close to 100% as possible? And like the Safari team's really sad when their line is below the 100% line more than other teams are. And like, that's also super exciting. And so that's also part of it where it's like, they work together to make sure they're implementing things at the right time. Cool. Anybody else? Great. Thanks for your time, y'all.